Hi, I'm Phil from Driftworks and welcome to another build episode on my GT1 inspired Murcielago project. Today I'm going to be looking at some improvements on the front suspension design. Those of you that have been watching for, 2 years I've been building this thing now, may recall that we've already done a lot of work to the front suspension on this car to get it to run as low as it does to work with the GT1 aero that's on the car. And still have good roll centre and good damper travel and stuff like that. But through the design, all the work that Craig and I did to build this in the first place, we've ended up with an issue with motion ratio of the damper basically, and that's as a result of clearance on the upper arm. So I'll quickly show you what I'm on about. Hopefully you're going to be able to see what I'm on about here. It's quite tight when the brake disc's on. So, here's the upper arm that we've made. Normally, the bottom mount of the coilover on a Murcielago is attached to this upper arm, and that gives you a really limited amount of travel, amount of damper length that you can have between the upper arm and the mount up there. So what we've done is, I think it's similar to the GT1 cars, is passed a longer damper through that upper arm and down onto the lower arm here, and not forgetting that this is all alongside inverting this. We basically created a drop knuckle here, so this is inverted. This pivot point previously was on the top of the upright here, so that's now changed that by, I think it was about 80mm, and equally we've done the same with an extension on the lower part of that. And very difficult to see this bit with no light. Let's have a look. But this was a very complicated bit of machining and fabrication here to do the same thing with the steering arm. So everything is, whatever it is, 80mm roll centre corrected. So these arms, when the car's got its wheels on the ground, these arms are in a really good angle. They're pretty much straight. So the issue for me is that because the damper now passes through that upper arm and mounts onto the lower arm here, I'm really limited with space here. You can see it looks very close, and I can assure you it's more than close. It's actually touching, and that's because I've pushed this mount out as far as I possibly can on this lower arm. The lower arm is much longer on the double wishbone setup than the top arm, and that's how you get sort of camber game, roll centre and stuff like that. But yeah, this is far outboard as can possibly go. I've also tried multiple spring rates right up to the 26 kilo spring that I have on here at the moment. And even with that, and that as far out as possible, the car is too soft at the front. It's not going to work. So rather than go absolutely silly with spring rates on the front, this really needs to move further outboard. And the only way I can do that is by gaining clearance on this upper arm, which in its current design is completely impossible. So what I'm going to do is have a look at 3D printing a test piece, a design that allows us to move that hopefully outboard at that point. I don't know, maybe 30mm, 40mm possibly, further outboard at that point. But because of how that works, that will mean that it'll maybe be 70mm, 80mm at this point. Very close to the upright there, I hope. It all starts with a very basic rough design in Fusion 360 with the help of Ed, who is our go-to guy for 3D printing here. What I've done is taken some measurements of centre point of inboard rod ends when they're wound in. This is wound out at the moment on this arm that we'd previously made. So I've measured the centre point from these and triangulated it all to basically give us a starting point. What we're also going to be doing is having the rod ends exactly at 90 degrees to the car, so it'll be easier to adjust if we need to. Most of the adjustment was already done in this, and this was pretty much locked off exactly where it needed to be for alignment. But it, as I say, it wasn't allowing the clearance here that was required. You can probably just see the spring's been making contact there. So let's have a look at what we can design with Ed. Okay, I'm here with Ed in the office. And we've skipped about 30 minutes of design work here, because this is actually a working office, believe it or not. If you can call what Starkey does work.
How dare you? How dare you?
But yeah, what we've ended up with here, you can see on the simulated bed here, is a very, very squeezed on orange basic suspension arm. And what this is it's up this way because we wanted to see what it was like printing it in one piece. You can split it into two and glue them together, but actually we just managed to squeeze this onto the bed and do it in one piece with the green here is the supporting structure. And just to explain essentially what it is, at the top here we have the outboard rod end, which is the thread is printed, which is really cool. And then at the bottom here, the inboard to M14 rod ends screw into this. And this basically allows us to have, hopefully, a bit more clearance here for the coilover to pass through. And it's a very rough design, really basic. It's not going to be this chunky when it's made out of aluminium, but yeah, it will hopefully prove the concept as long as it prints. How long is that going to take to print?
A mere 20 hours.
20? Okay, see you tomorrow. Exactly 20 hours later. Welcome to the studio / mess room / 3D printing room.
Well, it's not a massive mess. It has warped slightly.
How has it? What's it? How can you tell it's warped?
You can see it's actually lifted on
the
the corners.
That doesn't look too bad. What is like?
No.
Less than. No, that one's. Yeah, that's pretty bad. That's like 1.5 mil, 2 mil, isn't it?
But we'll see.
It'll still, hopefully.
Ultimately, you should see if it fits.
Yeah. So it's hollow, I take it, isn't it?
I think it was 20%. I think we did it at.
So I guess the time lapse, if it works, will show us. Well, that was easy.
Just needs to clean
Just needs to scrape that down, and yeah, hopefully should be able to just screw the rod ends right into it.
Yeah. So it's got the threads.
It's some kind of witchcraft magic, this, isn't it? He says before he's tried it. Okay, I'll give that a clean up and see how we get on. Thank you all.
Lovely.
Don't know what I was complaining about the mess in that room for. It's an absolute pigsty out here. Been doing the exhaust and everything on the car. Most of that's already come off. It doesn't really matter because it doesn't affect the clearance here, which is the problem. And because that side appears to have warped a little bit, I'm just going to send a tap through that because there's a good chance if it's warped that edge, it might have warped the actual threads that it's printed in there too. Too bad. Now, one thing I might have to do is actually cut that rod end down because there's far too much thread going to poke through to the other side, and that is the clearance that we need. So, yeah, what I'll probably do is just quickly knock, let's say 12 mil off that. God damn it. it looks like it's going to have that clearance issue that we talked about here.
And that bit.
Yeah, so when it's turning, but then if I can get,
because we can push that out to the right as much as we like, really. It just obviously reduces a little bit of the strength.
Yeah, I think that's like pretty much absolutely perfect. If you have a look underneath there, where that suspension mount is now compared to where it was, that's solving my motion ratio problem dramatically, like the perfect amount. So as long as we can get the clearance for the knuckle to steer here without compromising strength, that's going to work amazingly well. It can literally go further than you want it to. So to start with, just to make sure I can get the correct amount of caster on this with this back rod end in the position that it is. It's not an exact science here, but this is how we measured the caster before we took anything off the car. So yeah, I think it was about 7 or 7.5 degrees. So I've got lots of range there, ranging from 8.8 to 4. So yeah, that's more than enough with that. So it kind of sits roughly, yeah, that's in the middle. That's perfectly in the middle. That's 7 degrees caster. As I say, it's not absolutely 7 degrees, but yeah, that's good enough for me to know that I'll be able to get it where I need it to go on the alignment machine. So that's really good. Now, steering clearance, which we factored into the design, but this did end up being quite thick. It's kind of oversized and over chunky with no radius on it at the moment at all. So the actual design of the arm will be very different to this. It will have a huge radius on it, top and bottom, inside and outside. But yeah, it's a bit tight. See, the actual casting of the upright itself will hit that in steering. So we need to make sure that the design allows for that. So yeah, that's a pretty damn successful first test. We have a pretty major clearance issue here with steering, so we'll need to make clearance here. And the reason why there's a bit of cardboard here is because I'm simulating how much thickness we can add to the top section of this. Because of the angle the shock sits at, the shock is very close to the arm at the bottom, but the top is quite far away. So I've just done a couple of photographs for reference to see how much we could increase that thickness at the top here, which would then allow us to take away some there with the redesign, maybe even just to scallop both sides. But that's really good. The result at the bottom here for the shock and how much further outboard it goes is 70 to 75 mil. So that is an incredible amount and will solve the problem. So yeah, well worth it. On to design number 2. Changed my mind. I'm going to use the Wuzzer and just clearance these contact points on this part, because it's basically going to get chucked away. So why not use it to get a more accurate idea of the relief that we need here. And then obviously in the CAD program we can build up the structure back behind it, is the hope. So yeah, I'm just going to set about this and grind some of this back, test the steering again. You can see I've had to take a lot of material out of this. It's a lot more at the top than it is at the bottom, but just to make sure that I've got enough clearance for full steering lock, but also obviously I've tested it by raising and lowering the hub at full steering lock each way as well, because obviously that makes a difference in terms of pivot as to what your clearance is here and here. So that's all good. That tells us what we need to know in terms of the clearance or scallop that we need to make into the new design, and then that will therefore tell us how much extra strength we need to add in elsewhere to make sure that the arm is still strong enough. What I am going to do just quickly is put a wheel on. The original design that we came up with, I had measured on full lock, testing how much space there was between the rim and the arm here and the rim and the arm here, but I just want to make sure while I've got the opportunity that that is still the case. We still do have clearance. Because the inboard mounts on that upper arm aren't in the correct place as well, they're moving about fore and aft, it's also going to affect clearance here. So again, it's not an exact science, it's just to give me a rough idea. Yeah, that way I had loads of clearance beforehand, so that's not the one I'm particularly worried about. It's more that way, so not too much drama. Perfect. It's still held together enough, and I can glue that back together so we can take our measurements. So yeah, back to the drawing board. I may have broken it slightly.
Oh no!
That's for you.
Sweet. Oh god, you've been chewing it.
So another half an hour of fun designing. And this is what we've ended up with. Now, how long is this going to take to print?
Well, the support was all wrong on the last time. It didn't need all that support, so it shouldn't take quite as long.
It's Friday, it's nearly home time, so I'll just come in and try it tomorrow. If you want to set it running.
Oh yeah.
Bring the heat.
Warming it up.
Okay, and go. 5:30 on a Saturday, but Hannah and I decided that we just couldn't sleep without knowing whether it had printed or not. And it appeared to look awesome. So yeah, we'll get around to fitting that on Monday and get you back to bed. What do you reckon? Transfer these rod ends over. Damn it. We were struggling with the threads in this, so we decided to just make it a hole and then I'd tap it but for some reason the hole is the wrong diameter, it's too big, so there's no material to tap. Balls. Happy Monday. What do you reckon happened?
The thread was failing on it, so I ended up doing the thread as a separate body, but I think, yeah.
It just hasn't attached to the final file that we've printed.
Yeah, so let's just print the thread.
Yeah, so we should see that piece there it looks like a separate piece. We should be able to just print that and glue it in basically, shouldn't we?
Yep.
And that should only take, what, an hour of printing?
No, that'll be quick.
Excellent. Quick is good. That's not what we wanted, but that appears to be something. Okay, extremely excessive tooling time. Yeah, that's going to go in, no worries, so just get a bit of glue on that. There you go, that's in there. I just need to let that dry before sending a tap through it, and well, hopefully it all shall be well enough just to do this next test. Oh yeah. There we go. Time for a test. So that's worked out really nicely. That is almost perfect. And I say almost because the notch that we've added here that you can just see there, we don't need it. We don't need it at all. It's got more than enough clearance without that, and if it was to ever get ever slightly too close there after I've done my proper final alignment or anything, I can just notch a tiny bit out myself. So that's absolutely brilliant news because it gives it its full strength, uncompromised arm. And yeah, we can just send it to Martin the machinist and see what he reckons to how bad our design is and how unmachinable it is. There you can see the clearance that we've got on full steering lock there, so that's worked out really nice too.
Right, start of the job. Obviously this is the 3D printed Driftworks tryout that they've used to check over what they're after. Just got to turn it into aluminium. Right, there we go. Right, it's got about an hour and a half to run. I don't think we need to see all of that. So this is the right hand, finished machining on the first dot. You can just see a bit of surface detail there, and the clearance in the middle. And we've got the setup for the opposite side. Just got to finish machining that. So lots of squaw. Coming towards the end of the job. You see a roughing path over the second side of the left hand. Just loaded 12mm ball cutter. round apart.
Bang, and we're back in the room with some fancy aluminium bits. Martin knocked these out in about a week, which is absolutely awesome. Fantastic job with them, and yeah, I'm just going to get them fitted to the car right now. Okay, there we go. One very posh upper suspension arm. It appears to have worked out perfectly, which you kind of would hope if you'd done the 3D printed prototype. But we did do the unthinkable and change the design ever so slightly after testing the plastic version. Luckily, it's all worked out really cool and worked out perfectly. The coilover has a new lower mount. You can just see here. So that's now in its new position, which is much further outboard, roughly about 70 mil, something like that. We're waiting for new hardware for the lower mount here, so nothing's actually completely finished, but clearance is checked. Clearance around the coilover spring is perfect. I am in the process of sorting out the rough geometry. As you can see, there's nuts missing and everything like that. The thing about sorting out the geometry on the front end of this car is you have basically a rod end that adjusts in and out here, same over here. You also have shims either side of the rod end, which allows you to move the inboard mounts on the arm forward and backwards. You then have an external rod end here, which can go in and out. On the bottom arms, you have the same thing, but as well as the in and out on the rod end, it's still got the eccentric bolts in it as well, so there's adjustment there. Basically, long and short of it is, if you count up all the possible points of adjustment on this car that I have on one side of the front suspension, there's 12 points of adjustment to get the wheel sitting in the arch where you want it, with the correct camber, with the correct caster, and that's 12 points of adjustment, possible points of adjustment, without even factoring in the coilover or the tie rod, the tie rod adjustment here. So it's very, very faffy because there's no turnbuckles on this. So every time I want to make an adjustment in length, adjustment of the rod end there, I have to drop the bolt out, give it a twist of the rod end in or out, then put the shims back in and put the bolt back in. So yeah, it's a little bit of a challenge, but it's essentially looking like it's going to work perfectly. I have to finish up this sort of rough adjustment and eventually get it onto our alignment rig. And there'll be a lot of faffing about with that, I imagine, to get it exactly where I want. 3D printing is just some kind of magic witchcraft for prototyping. I absolutely love the process, and I love working out the design with Ed, and then having Martin just make something awesome in metal at the end of it. Being on the car is it's fantastic, isn't it? So that'll probably do it for this episode. Thanks very much for watching, as always. Give us a like if you feel like it. And yeah, we'll see you in the next one. Cheers, bye.
At Driftworks, we've helped over 50,000 happy customers since 2004. Our huge online parts store is simple to use, with superb shipping rates to anywhere in the world, and finance options available for UK customers. We live and breathe wheel fitment, so if you have any questions about your own car or any of our products before placing an order, please drop us an email at shop@driftworks.com or give us a call. Thanks for watching.